Friends, in this one, I'm going to show you some magic of using complex numbers to find a trig identity for tangent of 2 theta. This is roughly based on the work of Tristan Needham's. He has an example there with 3 theta, but I'll do it with 2 theta. Okay, so we have tangent of 2 theta. Let's define, as he does, a nice complex number that says z is equal to 1 plus, and then I, and then this position put t. Now, what is this big T? This big T just stands for tangent of theta this way. Now let's understand what happens when you multiply complex numbers together. What happens? Well, think about it, right? Think about it in exponential forms. If you have like e raised to the I theta, it's a basic complex number in exponential form. And then if you do this, e raised to the I theta this way, right? And then you square it, or if you like, multiply by 2 up there, you're going to have e raised to the I of 2 theta. In other words, the angle just gets doubled, doesn't it? Okay, so that's important to understand because that means the following then. When I do the z squared, it's pretty much the same thing. I'm just using z to represent the number instead of, say, e to the I theta. But the same logic applies. So I'm going to square then 1 plus I t this way. Okay, I'll show you all the work at the end, so make sure you stay tuned until the end. And also make sure you square this side. So now let's go through this. You can just expand this the normal way. So it's going to be 1 plus 2ti, and then plus that it quantity squared this way. So 1 plus, and then 2ti, and then now I squared, it will give you a negative t squared right here. Let's group the parts together. So it's going to be 1 minus t squared, and then plus 2ti. Now think about this a little bit, okay? Think about the complex numbers. So let me draw a graph here. So here's a little graph. And imagine the complex number. Now imagine we have a complex number that looks like the following here. Imagine this is the first one that just says like this, 1 plus it. When you square this number, of course, all it does is just doubles the angle, right? Kind of like brings the angle up to here. But for that angle, we'll call that then 2 theta right here. Let me kind of point to it. Okay, I'll make this smaller so it fits better, right? So 2 theta is like this big angle up to, say, this red line. Then what are the components? Well, the vertical one would be this one right here. That would be this leg right here, right? And the horizontal one would be this leg right here. So in other words, relating it to this expression here, what we have then is the following. Let me move this aside or make it smaller. That's for this one. That means for the new one, whatever this part is right here, okay, let me underline it like this. That represents the vertical leg, and whatever this part is right here, let me underline that now, that represents the horizontal leg, doesn't it? Which means, in other words, that the tangent of double the angle is just the vertical divided by the horizontal as usual. It's going to be 2t divided by 1 minus t squared. But remember, we defined big T as the tangent function. So in other words, we just end up here with tangent of 2 theta equals 2 tan theta divided by 1 minus tan squared of theta. But it just shows the amazing powers of complex numbers. I've zoomed back out so you can see all the work from top to bottom. If you like math videos of a more interesting or non-routine or more advanced nature, please be sure to subscribe and like.